Alright class, so our next unit is on counting calories, and sometimes you don't want to count calories, other times you do. When you come to In-N-Out Burger, you don't want to know the calories, but the food is awesome. So anyways, enjoy learning a little bit about exothermic and endothermic reactions.
Alright, so outside our condo we have a bunch of icicles, you can see behind me, and I ripped one off, so I have some icicle, some fresh ice, in my hand. And I'm sure you know that if you put ice in your hand, it starts to melt. Alright, so in this process, heat is being transferred, and heat is going from one place into another place. And in that process, I'm causing a phase change in this case. So I have ice, which is liquid water, and as you can see dropping off my hand is some ice is frozen water, and in my hand I have some liquid water, and essentially heat is going from my hand, because my body's making quite a bit of heat, into the ice. Alright? And that absorption of energy by the ice causes the ice to change into water. So, that is an endothermic reaction. And you have a piece of nice Colorado ice you can remember as you think about that. Alright, so here we are. We are going to put this cup of water, this glass of water, in the freezer. And we'll kind of pause it and come back in an hour or so and kind of discuss what we see. Pizza, ice cream, fabulous. I know, we'll leave the glass in there. Alright, so it's been about an hour, and as we look inside the freezer, as I pick this up, you can kind of see it frozen on the sides. A little bit of liquid right on the top still, but it's mostly frozen. So, in this process, unlike the icicle, in this process, what's happening is, if you think of the water, its molecules, when it's a liquid, its molecules are moving pretty quickly, and heat is leaving here going into the freezer. As that heat leaves, our molecules start moving slowly and slowly, and more slowly and more slowly and more slowly. And as they move more slowly, they become attracted to each other, and as they become attracted to each other, they turn into ice. So anyways, in this process, instead of requiring heat to freeze, when something freezes, it actually releases heat to the surroundings and the area around it, which is kind of weird because freezing, it's cold, but it's actually releasing heat as something freezes.
Alright, so this podcast started off with a couple videos, and the two videos basically were describing two different situations. The first was an endothermic reaction. And you might just put endothermic in your notes. And the second was an exothermic reaction. And just knowing the Greek prefixes here, endo and exo, and knowing that thermic has to do with heat, it's fairly easy to know what these words mean. So endothermic reactions, or really endothermic processes, where heat moves. Okay, so heat moves from the surroundings into, just like endo, into the system. Alright? And conversely, an exothermic reaction is when heat moves from the system, whatever the system is, into the surroundings. Right? So two words, endothermic and exothermic. They both have to do with heat, and it's where the system, or where heat is moving. So real quickly, the system, this is important to define. The system is whatever is changing. Okay? So when I say system is what changes. And by what changes, we are talking about molecules. So molecules, atoms, at the very heart of it, whatever is changing. So when we looked at the ice melting, What was changing? Well, the molecules in ice were locked into one place. They were a solid, and as they melted, they kind of lost those attractions that locked them into place, so they started flowing, and as they flowed, they became runny, or they became like a liquid. Okay, so what was changing? The water molecules were changing. The surroundings is the rest of the universe. All right, so it's a very, 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 very broad system, or very broad definition. All right, so a couple things. If we have a reaction, so we just have reactants turning into products. We're going to do two of these. So again, reactants into products. So if we have an exothermic, or we'll do endothermic to begin with. So endo is going to be our top one, and exo is going to be our bottom one. All right. So I want to know, where would we actually put the word heat in each of these situations? So in an endothermic reaction, so now we're talking about a reaction instead of a process. In an endothermic reaction, heat is moving into our reaction, or heat is being required. So in that sense, if we have an endothermic reaction, we would actually write the word heat on the reactant side. So we might have heat plus reactants yields products. If we have an exothermic reaction, we would have reactant plus product, or yields product plus heat. So a good example of this would be our Bunsen burners. All right, there is natural gas, which is methane, ethane, and we heat that, or we light a match, it burns, and as it's burning, as it's combusting, it's a combustion reaction, it's giving off a bunch of heat. Alright, the last thing we're going to look at in this podcast is simply phase changes. There are a couple of them in the videos, but as we go from solid to liquid, and from liquid to gas, alright, there's words for these things. So as we go from solid to liquid, it's called melting. And as we go from liquid to gas, we might say boiling, vaporization, evaporation. Typically in science we'll call it vaporization. If it's at its boiling point, it's boiling, but stuff can evaporate when it's not boiling. All right. If we go the opposite way, if we go from gas to liquid, that's known as condensing or condensation. And as we go from liquid to solid, that is known as freezing. Right. And if you have these in your notes this way, as we go left to right, or right to left, we either have an exothermic or endothermic reaction. All right. So in my mind, it's easiest to think of if we melt something or vaporize something, it requires heat to do that. All right. So if it requires heat, I am going to say that it is endothermic. All right. I'm actually going to draw this in blue. So again, going from left to right, we have an endothermic process. Okay. It requires heat to melt something. Okay, especially if we're thinking of something like metal being melted, it requires a tremendous amount of heat to do that. And if we're melting something like ice, it melts pretty easily. We can just melt that in our hand. Conversely, if we're going the other direction, all right, so if we are going from gas to liquid or liquid to solid, this is what doesn't make as much sense. So I always know the one, melting requires energy, but the opposite is also true. So if I go from a liquid to a solid, all right, that is an exothermic process. And hopefully in the video I tried to do a little bit of drawing on that when I was looking at the ice in the freezer. But as we freeze something, it actually releases heat. Heat is moving out of our water in this case into the freezer. And as energy or heat is leaving our liquid water, our molecules start slowing down and they freeze. How come? Because energy is leaving. All right. So that is your notes for tonight.